Hello everyone. For today's video, we'll be looking at quadratic equations, specifically on how to use your discriminant formula over here. Now, your discriminant formula is actually extracted from your quadratic formula, where it says b squared minus 4ac can either be a positive value, where it is more than 0 when you have two real roots, or b squared minus 4ac equals to 0 when they say that it is a tangent line or only intersects at one point, okay? Or lastly, b squared minus 4ac is a negative value. It is actually less than 0, where it actually does not touch the graph. In today's video, I'll show you a few examples, one for each of them, okay? So let's start with this first question here. Find the values of k for which the line y equals to x minus 3 intersects the curve y equals to k squared x squared plus 5kx plus 1 at two distinct points. Now, when I'm starting this question, I must first identify that I first have a straight line and I also have a quadratic line here, a curved line, okay? It doesn't always have to be a quadratic, but if in this case it is, so it is actually going to look something like the first picture I've drawn here, a quadratic curve, okay, and then a straight line, and it cuts two distinct points. Two distinct points meaning to say you can have two roots. So in most of the cases, all the time, you're supposed to substitute this y into this equation over here, starting off with x minus 3 is equals to k squared x squared plus 5kx plus 1. From here, we need to equate the equation to 0, meaning to say we move everything from the left to the right. K squared x squared plus 5kx minus x, which is from here, okay, plus 1 plus 3. Now that we have this equation that will equals to 0, we will then factorize out the x so that we can identify in our quadratic equations the a, b, and c properly. In this case here, it's going to be k squared x squared plus 5k minus x, minus 1 bracket x. We factorized out the x in this case here, okay, from this whole part, and plus 4 equals to 0. From here, identify that a equals to k squared, b equals to 5k minus 1, okay, and c equals to 4. Then substitute it into our discriminant formula. B squared minus 4ac is more than 0. So b squared, 5k minus 1 square minus 4ac is more than 0. Open up this bracket here. You have 25k squared minus 10k plus 1. Over here, you're going to get minus 16k squared, more than 0. Simplify this quadratic equation here. 9k squared minus 10k plus 1 is supposed to be more than 0. 9k minus 1, and then this is going to be k minus 1. 9k, 9 minus 1, yep, more than 0. So now, in order to determine where the inequality is going to face, we need to first identify that this, if plotted out as a quadratic function, quadratic graph, is going to look something like this, because it's a positive k squared, okay? And these points here are going to be your intercepting values. In this case here, k would have been 1 over 9, and this case here, k would be 1, okay? So this is obviously where 1 over 9 is, and this is where 1 is supposed to be. Now, our final answer, it has to be an inequality. So since we have this, where the value has to be more than 0, I can say that the arrows here should point upwards, meaning to say these are the points that we are looking for from here to here to here, okay? So your final answer should be k is less than 1 over 9 and k is more than 1. because it's these two parts here. Okay. Looking at our next example question, the line y equals to kx plus 3, where k is a positive constant, is a tangent to the curve x squared minus 2x plus y squared equals to 8 at the point P. Find the value of k. In this case of our example question here, it is a tangent. So it's going to look something like this. Again, identifying this is your straight line, something like this, and this is your curved line, something like this. Then we know that this is where point P is supposed to be. Since they only touch each other at one specific point, then the discriminant formula b squared minus 4ac is supposed to equals to 0. Now, again, first step in these kind of questions is to substitute this equation into this equation here. You would have gotten x squared minus 2x plus y squared, which was kx plus 3 from the left here, square equals to 8. Expand your bracket from here, x squared minus 2x plus k squared x squared plus 6kx plus 9. Bring the 8 over, minus 8 equals to 0. From here, factorize out the x squares, the x, and separate them. Here is going to be 1 plus k squared x squared. This will be your a. Here is going to be plus, put the 6k in front, 6k minus 2x, and lastly, plus 9 minus 8, which is supposed to be just plus 1, equals to 0. And now we have identified that a is this, 1 plus k squared, b is 6k minus 2, and c is equals to 1. Okay? Now, from here, substitute it into our discriminant formula, b squared minus 4ac is equals to 0. And from here, proceed to solving for the value of k. Open up this expansion is 36k squared minus 24k plus 4. Here is going to be minus 4 minus 4k squared equals to 0. Okay. Simplify this equation, 32k squared minus 24k, 4 plus minus 4, 0. And from here, solve your quadratic equation using your calculator. 32 minus 24, 0. You would have gotten k would either equals to 0 or k is equals to 3 over 4. But now, looking back at your equation, k is a positive value. Sorry, looking back at your question, k is a positive constant, right? So we cannot accept the value for k equals to 0 because this is not a positive constant. In fact, if k was equals to 0, 0x plus 3, you're going to just have a straight line of y equals to 3. We do not accept that, okay? So k can only be equals to 3 over 4 in this case. Okay. Now, let's look at the next example question here. The line y equals to kx minus 5, where k is a positive constant, is a tangent to the curve y equals to x squared plus 4x at the point A. Find the exact value of k. In this case, again, it is a tangent. So a tangent meaning to say b squared minus 4ac is equals to 0. Substitute this equation into here one more time. Kx minus 5 is equals to x squared plus 4x. Yeah, that's it. Group them together. X squared minus, plus 4x first, then only minus kx minus plus 5 is equals to 0. Group up the x values here. X squared plus 4 minus k bracket x plus 5 equals to 0. Now, use your discriminant formula one more time. B square, which is here, 4 minus k square. B square minus 4a, which is 1. C is equals to 0. Expand this bracket. 16 minus 8k plus k square minus 20 equals to 0. Rearrange your equation. Minus 4 equals to 0. Now, in this case here, they are asking for exact value of k. So what I should do is use the quadratic formula. Quadratic formula is supposed to be negative b plus minus the square root of b square minus 4ac over 2a. And substitute these values into here to solve the value for k. Okay, so substituting in negative 8 plus minus the square root of b square, negative 8 square minus 4ac over 2a. Then simplifying this equation, k should equals to 8 plus minus the square root of this number 64 plus 16. So it's 80 over 2a. And then from here, simplifying the equation, I should be able to get 4 plus minus the square root of 80 over 2. Since it is a positive constant, square root 80 over 2 is supposed to be 4.4, then that's why we will not accept the negative value here, because they are asking for the positive constant, right? Then final answer should just be 4 plus square root of 80 over 2. If we type this into the calculator, this would roughly be 8.4. But if we did minus, it would result in a negative answer. So this is the only acceptable answer. Okay. Now, lastly, one last example here. Find the values of k for which line y equals to kx plus 3 does not meet the curve y equals to x squared plus 5x plus 12. Does not meet the curve, meaning to say b squared minus 4ac is less than 0. Okay, just like what we've been doing before, always substitute the equate both the equations here. Kx plus 3 equals to x squared plus 5x plus 12. Okay, then move the equation over. X squared plus 5x minus kx plus 12 minus 3 equals to 0. Then from here, group up the equations. X squared plus 5 minus kx plus 9 equals to 0. Substitute it into your discriminant. B squared minus 4ac is less than 0 in this case. Less than 0. Okay, open up this bracket here. 25 minus 10k plus k squared minus 36 is less than 0. All right, simplify this equation here. K squared minus 10k, 25 minus 36, negative 11 is less than 0, right? Then, okay, from here, factorize this. K is either minus 1 or positive 1, or k is minus 11, less than 0. Now, from here, we should sketch the graph. Sketch the graph so that you have a kx squared and you want it to be less than 0. Obviously, since k is plus 1 here, then is negative 1 on the graph, and k is 11 over here. Okay, 11. Since you want it to be less than 0, That means the part of the graph that is less than 0 is the values inside here. So the acceptable k values has got to be in between 11 and -1. Okay. Oh, I just realized there's one more question at the bottom. So let's do this as well. Maybe make it a quick one. To find the values of k for which the line y does not meet the curve. Again, it is a no root equation. So b squared minus 4ac is less than 0. So equate both of them first. Kx is equals to 9x squared minus 3k plus 1x plus 5. Okay, move it over so that we can have an equal 0 equation. 9x squared minus 3k plus 1x plus 2kx plus 5 minus 1. Okay, group this up one more time. 9x squared minus 3k plus 1 minus 2k, I gotta assume, because that's how when you open the bracket, you get back positive 2k, right? Then plus 4. Okay, plus 4 here. Then what you're going to do, then you would just have a positive k minus 3k. Simplify the inside, 9x squared minus k plus 1x plus 4 is equals to 0. Okay, equals to 0 for all of them. Then substitute it into your discriminant formula. B squared minus 4ac is less than 0. Expand the bracket. K squared plus 2k plus 1 minus 16. 4 times 4 times 9. 144 is less than 0. Then simplify. K squared plus 2k minus 143 less than 0. Type this into your calculator. 1, 2 minus 143. And then in this case here, factorized answer is k plus 11. So k equals to 11. Sorry, minus 11. So k equals to 11. And k plus 13. So k equals to -13. Again, when we sketch out this graph at the bottom here, it will look something like this. And these are the values here for -13 and 11. Okay, you want it to be less than 0. So it's the part of the graph that is below this flat line here. Meaning to say, again, it is the values in between. And therefore, the possible values for k has got to be in between 11 and -13. Okay, and that will be it for this topic here. Hope it helped you guys. Thank you.